All right, very important concept here that we're going to have to make sure we understand well before we really move on to some of those higher order functions we need to take care of in our essential outcomes. We have to be able to solve linear equations. Okay, linear, what you have to understand is means when we're talking about my highest power of x is x to the first. Equation again now means we're going to start looking at equal signs. So what I'm looking to get to eventually is this idea of x equals some number. Okay, and that number is what's going to make my equation balance, meaning both sides will be the same. So here's my general steps that I have, and what I'd like you to do is actually just pause the video, write these down, because what I'm going to do is go through each one of these individually, okay, and show you an equation where we can do each of these steps, okay, and you can add a few notes and then leave a little space between them. So pause your video and then come back and we'll look at examples of each. All right, first situation is grouping symbols. We need to get rid of our grouping symbols, okay? Just like when we did order of operations in terms of simplifying our expressions, we got rid of grouping symbols. Now, a couple things. Yes, this is where we should think about your distribution. Okay, which means I got to take this number on the outside, the 4, and I have to distribute it through the parentheses. Okay, I mean I have to take it times everything on the inside. So I need to take the 4 times the x, the 4 times the 2x, the 4 times the negative 3. But now my parentheses are gone. Now, at the same time, okay, one of the other things that comes up is, hey, with order of operations, the idea was that if I have a grouping symbol, what I really should be doing is simplifying what's inside them. And so that's what I truly should be doing, is putting those things together on the inside. Okay, I should be putting that x and that 2x together to get 3x's. And now come in and distribute the 4 through that set of parentheses. But if you notice, if I put my 4x and my 8x together, I'm going to get to 12x. So I would get to the same point. So, and the other thing is you're going to find out, if you remember writing down some things, one of the steps was combining like terms. So we're going to at some point combine like terms. I mostly would tell people to do the left one first, get rid of the parentheses, and then the combining piece will come into play in a little bit. Now, like I said, I'm not going to finish these all out. I just want to look at that one step with each one. All right, now I know fractions can give us issues. Okay, but notice what I say up there. It says multiply by common denominator. It doesn't say least common. Okay, if I were to find least common, what I have to do is look at multiples. Okay, and that can take some more time. My suggestion when you're looking for a common denominator, just take your denominators, no matter how many you have, multiply them together, and that becomes the denominator to use. Okay, yeah, sometimes the numbers are going to get larger, but we can use our calculator. So my common denominator is 6 in this case. What I have to do is make sure I multiply everybody by that 6. Okay. Because most of the time we don't have an issue multiplying the fractions by the 6. But what we forget is this little 4 here, because it's not a fraction. But what we're really doing is I'm taking this 1/2 x minus 4 equal to 5/3. And our rules for equations say if I do something to one side, I got to do it to the other side. Now all I'm trying to do is bypass this step where I add parentheses and then I distribute. Okay, I get to the same place. It's just a little quicker. Okay, so now we've actually done all that, but we can jump right into simplifying this out. Now, here's my suggestion when you deal with fractions. Okay, when you deal with fractions, what you do again is you multiply your numerators, you multiply your denominators. Now, we're not putting anything in the denominator. Okay, we're putting something in the numerator. So what I'm going to do is multiply the 6 times the 1, and then add my 2. The x is still there. And we should always divide and get an integer value. We should not get decimals. If I get a decimal, what that means is that I didn't pick the correct denominator. Okay, and then I got minus 4 times 6, so minus 24. Same thing here. I'm going to take 5 times 6, and then I'm going to divide it by 3. And sometimes, yes, it may be that I have to pull out the calculator to do the division, but fine. At this point, there should no longer be any fractions in my equation. And so that relieves our stress level quite a bit sometimes if I don't see fractions anymore. So it's quite an easy way to get rid of them. All right, step 3, what we want to do is combine like terms on each side. What we're truly doing is I'm taking and going back to simplifying expressions, and I'm going to treat each side as an expression. And so I'm going to combine like terms. So I have an 8x and a 2x, so if I put them together, there's 10 of them. I have a constant that's all by itself. And now I'm going to do the same thing over here on the left side, or on the right side, sorry. And I like to put my variable piece first, so since the 4x is the negative 4x is the only one there, but then I can combine the 1 and the negative 7, again, more negatives, big minus small. Okay. So that's a fairly simple step. What happens here where mistakes occur is that sometimes people will do this. Okay. And what happened is I simply changed the left side of my equation. There's no balance. You can't change one side without changing the other. So I have to make sure I do it to both sides of my equation. Okay. So think of it more as you have an expression on each side of the equal sign that we want to simplify like we did in the first section. All right, now I need to get my variable on the same side. I'm trying to get x equals something. Okay, I'm not trying to get x equals x plus or minus something. I want to get x equals. So I want to get them on the same side, and I always talk about moving or get rid of the smaller of the two, because what happens is that'll keep my variable positive. Okay, which becomes important when we start getting into inequalities where if you multiply or divide by negative, we have to switch the direction. Okay, so when I look at them, I notice that the negative 2x is the smaller. So to get rid of it, okay, this is actually an addition subtraction step. I want to do the opposite. The opposite of a negative 2 is a positive 2, and because it's with the x, I have to actually do a positive 2x. Now, I'm going to put it with like terms when I put it on the other side, because again, there's that balance. Okay, so I'm going to match it up with the x term over here on the right side. Opposites go to 0. 0 and a negative 5. Okay, anytime we put 0 with something, I get that something back. 4x's, 2x's. Now I have one x in my equation. Well, what if my teacher says my x has to be on the left side? Well, you know what? Keep working. Get something equal to x, and then you can just switch it around. Okay, there's nothing wrong with doing that. Okay, so that's getting your variables onto the same side. Okay. Now it should be easy because we're to a two-step situation, which is, you know, we spent a lot of time in a high school algebra or an algebra 1 course taking care of that, getting rid of your constant. Okay, and actually I don't want this equation, I want this one. Okay, this is my constant. This is the part without the variable. And how do I know I don't want to deal with the 4? Because I want to get the x all by itself. So I got to get rid of the negative 2, and I got to get rid of the negative 5 to get x all by itself. Well, the negative 2 is attached to it, and the next step we'll talk about as a coefficient. This is my constant. Add 5. The reason we want it, again, is I hate the term cancel. They add to 0. So I got negative 2x with 0, and like I just said earlier, anything with 0 is at anything. Okay. It's a fairly simple one there. Okay. Multiply or divide by your coefficient. Okay. Again, coefficient is the number in front of the variable. Okay. Number in front. Okay. And that's how I know which order to go with it. Go with the one that's not attached to the variable and then get rid of that one. So this is multiplication, do the opposite, divide. Okay. Again, doesn't cancel, multiplies to 1. 1 times x, anytime you multiply by 1, you get that back. Now, if you end up with a fraction here, okay, just leave it as a fraction. Okay, and you can always look at that in your calculator, 23 divided by 7. Okay. You get a decimal. Okay, don't round it off, it's better to leave it as a fraction. Okay. Now, like I said, if that coefficient is a fraction, say for some reason you didn't get rid of your fractions on step number 2, and so you still have a fraction left here. Take care of it in 2 steps. Okay. Number 1, I'm going to multiply by my denominator, because this says divided by 5. The opposite of dividing by 5 is to multiply by 5. And think about what we did when we got rid of the fractions. You multiplied the top, multiplied the bottom, 2x, because again, these two multiplied to 1. And then 20 divided by 5. And then, I don't even really need step 2 because almost every one of us should recognize, hey, I'm going to divide both sides by 2 now. Done. And then your check. Okay, this one, like I said, a lot of people don't like to do this one, but it's very easy to do, especially if I use my calculator. I went through and solved 4x minus 3 equals 17. Got x equal 5. So if I go back in here, what I want to do is I want to evaluate, going back to the simplifying case, evaluate for when x equals 5. We'll type it in. 4, like I said, put the parentheses there. 5 minus 3. Better give me 17. If it doesn't, I did something wrong. Even when I have those big, long, ugly expressions on both sides of my equal sign, I can do the same thing. I evaluate for the left side, evaluate for the right side, and hopefully get the same thing. All right, so quickly going to go through a couple of examples. I'm getting short on time here, but here's an example where I have a fraction. I can do this in a couple ways. I can get rid of it by multiplying everybody by 5. Reason 5, it's the only denominator. Okay, so 20 divided by 5 becomes 4x. Plus, now it's 5 divided by 8, because we got to remember everybody gets multiplied by the 5, and then 5 times the 20. Okay, so I started with the fraction. Okay, I don't have any terms to combine. I'm already actually down here step for a 2-step. Get rid of my 40. Okay, now I'm ready to get rid of my coefficient. Divide by 4. X equals 15. So now what I'm going to do is go back and check it, like I said. And yeah, I know there's a fraction here, but put the parentheses where you had the variable. Put what you believe it to be, 15. So you got 4/5. Well, 4/5 is the same as 4 divided by 5. Then your parentheses, 15. Plus 8, and I did get my 20 like I needed. Now, another thing I could have done with this one, and since that's my only fraction, I could have went right to the 2-step situation. I could have got rid of my 8. I could have multiplied by my denominator. Okay, because again, what basically they're gone. 4x equals 60. And then divide by the 4, which leads me to x equals 15 as well. Okay. All right, I'm going to go through this one, and again, rather quickly. You may need to stop after each step, maybe, because I'm going to go through each one. Step number 1, groupings. Okay, distribute. So multiply by 3. Distribute, and it's a -2, and here's times a -1, so positive 2x, negative and positive, -2 times 7. Now, that's not in the parentheses, so it doesn't get multiplied by the -2. Step 2, don't have to do. There aren't any fractions. Okay, so step 3, let's combine terms. So I'm looking at this side. Okay, we're all good. There's an x, there's a constant, can't put anything together. But on this side, I got 2 terms involving x. I got 2 and -12, so again, I'm adding. Okay, I'm adding, I'm combining. So I have more negatives, big minus small, 12 minus 2. Variable same side. Okay, looking for the smaller. Get rid of the -10 with the opposite, a +10. Goes to 0. All that's left, don't lose your negative with the 14. Over here, put those x's together, 25 of them. We're at a 2-step. Add, subtract, constant. Here's my variable, x. Get rid of the constant, the part without the variable. Get rid of the -24, +24. Gone. Again, positive and a negative, more positives, 24 minus 14. Divide by 25. Okay. Now, here's a quick trick. Okay, if I go in there and I take 10 divided by 25, enter, math, change it into a fraction, get 2/5. All right, good luck with this.